we tried to position the context of this topic by saying extension 2 motion is just like extension 1 motion, but we added something. What did we add? We added mass, good. So just like before we had displacement, right, and its units were, say, meters, that's standard, right? Then when we differentiated, just like the question we just did, right, you get velocity, and you differentiate it with respect to time, so what units would you associate with velocity? Meters per second, right? And then you go one more time, you're still differentiating with respect to time, so you get another time unit on the denominator. So far, so good, okay? And then we added mass into the picture. We thought, okay, let's just think about kilograms as our basic unit, okay? So then we said if you take velocity and you bring mass into play, right? What did we call that? We had a name, displacement, velocity, acceleration, mass, what was this called? Momentum, good. And its units were kilogram meters per second, because it was this times mass, right? And then we did the same thing, and this is the force that we've been familiar with, okay? Now, because this is such an important unit, that's why we gave it the name newtons. Okay, but now here's the important thing, and here's where the new concept comes in, okay? Newtons, 1 Newton is equivalent to one of these, okay? So let's try to unpack that. 1 Newton, okay? It's the amount of force required to do what? Well, the units themselves tell you, okay? It's the force required to move 1 kilogram, or to accelerate rather, 1 kilogram. How much? How much? Well, there's still no other numbers in here, right? So it'll be 1 kilogram, 1 meter per 1 second per 1 second, right? So to accelerate 1 kilogram at 1 meter per second squared. Now, this is all fine and good. And when we're in kind of like, made up mathematics land, where we just sort of, here's an equation and here are numbers and it's a cubic, where did this come from? Doesn't matter, it's just imagined, right? But when you come into the real world, this is kind of, well, it's not that, there's a more common sort of acceleration that we have to deal with that comes into all sorts of questions, and we've already been dealing with it in extension 1 motion. Namely, not 1 meter per second squared, but 9.8 meters per second squared. Now, where does this number come from? It comes from gravity, right? Now, we've dealt with this under projectile motion already, okay? But if you think about the same idea, but instead of 1 kilo at 1 meter per second, but if you make it 1 kilo at 9.8 meters per second, right? This is not a Newton anymore. Like, this is exactly 9.8 times bigger than a Newton. But this is the force that results from gravity, at least gravity on our planet, okay? So, rather than Newtons, they introduced this. I'll just stay with this. They introduced this, and it comes up in the exercise, right? So rather than thinking about, okay, just Newtons, which, these are just kind of out in mid-air, no context. When you are thinking about Earth, and you're thinking about the gravity, right? This is the force that's required to accelerate a kilo at this rate, which is exactly the rate that the Earth does, okay? By the way, just as a side note, I don't know if you've heard how in science, in physics, there's all these forces, fundamental forces, right? And they say gravity, it's super, super weak, right? It's the weakest of the lot, okay? But we experience it all the time. Why is it that the weakest force is the one that we're actually most familiar with? And the answer is, to get to this, right? What is this based on? Where does this come from? Think back to our laws of motion, right? This force and the corresponding acceleration, it comes from whatever is exerting that force, which in this case is, it's the Earth, right? There you go. There's Australia. That's awful. Sorry, you get the idea. Now, the Earth is huge. The Earth is enormous, right? All of this mass is required to exert this acceleration, okay? And this particular number is the number that we're interested in. So when you see 1 kilogram weight, it's its own unit, And because it's exactly 9.8 times bigger than a newton, right, it's equal to 9.8 newtons. Okay? So you'll see both of these units, kilograms weight and newtons, and you need to be able to recognize and convert.